Our next presentation is going to be from Mark Henderson of Equilibrium, titled Ziggurat, the Network Testing and Stability Framework for Zcash. Like the multi-step pyramids of antiquity, Ziggurat stands to provide multiple layers of stability for your peer-to-peer network. By reverse engineering the network protocol using lightweight synthetic nodes, Ziggurat provides Zcash node developers with the foundation of reliability, performance, and scalability needed to realize their true potential. In this talk, Mark will discuss the Ziggurat process and as well as cover some of the findings and insights that he has gleaned from their work. And with that, take it away, Mark.
Thank you, John. All right. Quick show of hands. Developers, business people, community members, other. Okay, cool. Just so I know kind of who I'm talking to here. Welcome, welcome. Future's not yet been written, right, folks? Well, check this out. Hold on, don't clap yet, don't clap yet. It's only a matter of time before something like this happens. This was our thesis going into our grant writing and the Ziggurat effort. It's only a matter of time before a network layer hack takes down an entire blockchain. We've seen some near misses, we've seen some interesting things, and I will say that you are all lucky that we found a lot of these things before somebody malicious did that was outfitted with a crawler and the same knowledge that we had. So let's go into some of this. We're going to go through an overview of the history of the project, motivation, all those things, and then we're going to go right into the Ziggurat process. Because that's what Ziggurat really is. It's not a piece of software. It's not a synthetic node, which it comprises, but it's really a process by which we test blockchains, and specifically the peer-to-peer networks in the blockchains. Both single node testing and multi-node network-wide testing. There will be QR codes in this talk, so get your phones ready because we're going to be linking to things and stuff like that, and I figured the best way to make this as accessible as possible, make it listenable and engaging is to include those, so be warned. Let's get into it. The first thing I got to say is that Ziggurat is not just me. There's people out there that are better at networking, better at Rust, better at React, things like that. It's a group of people. It's also not just Equilibrium, but our sister company, Eiger. Luca is part of that here. And this links to the README contributor section. We're also open to contributors, so if you're interested in contributing, you should. Networks are vulnerable, period, and peer-to-peer networking is hard. Things like encrypted handshakes, things like scalability, availability, peer-to-peer networking is not a client-server model. The entire system is sort of encapsulated within one peer, and those connect to other fully encapsulated systems that need to communicate, and bad things can happen. Like you can get a polluted peer list. You could halt the network on the roll-up side of a bridge. That should sound familiar to some of you. And you can just take it down by sending bad messages across the network layer. That was one thing we found was that, I won't get into the details. If you're here to find out findings like specifics about bad things that can happen, I'm not going to be the guy that tells the bad guys how to do that, but I will sort of give you an overview of things like sending a nasty message to a peer that can just completely crash the node. And if somebody was outfitted with a crawler and that knowledge, they could probably take down the entire network in like 20 minutes. Luckily, those findings that we've had have been fixed, and it's a little bit safer. Can never guarantee full safety, but here we are. Has anybody read the Trail of Bits DARPA report that came out in 2021? You have. Horrifying. In terms of like what centrality means and the different measures of centrality. One of them was networking and the network metrics involved, which we're going to get into later. Solana, Arbitrum, there was like 4 yesterday of things. They weren't quite network layer, but they were close. So we'll see. That being said, Zcash is awesome. I think it's a great mix of the OG cypherpunk and state-of-the-art zero knowledge stuff. As far as a client goes, we are a consultancy, and as far as clients goes, it's one of the best groups of people that we've ever worked with. So that's really cool. So at the risk of my personal reputation, I will say that I'm bullish on Zec. All right. That's what I'm talking about. Is Hanu here? This guy, the Zcash team? No? Okay. Just checking. Funding history has been over the course of 3 grants, starting with simple single node testing to ensure that Zebra and Zcash D could talk to each other. They couldn't quite talk to each other, but now they can. And then we moved into the full network wide, and then we moved into some really fun advanced stuff that we'll touch upon late in the talk. Why? It's like the multi-step pyramids, blah, 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 blah. It's a cool word that starts with Z. So we picked that. Any Sumerians in the audience? Yeah? Dude, sick. Nice work. Yeah. All right, and thus Ziggurat, the project, was born. And here's how we go about doing things. We have what they call a synthetic node. This is a very scientific diagram of our synthetic node here. It's a lightweight Zcash node that does not participate in consensus or anything else. It only speaks networking, and it can sort of go and mock being a Zcash node. It knows the handshake. It knows what to do with peer lists. It knows what to do with block requests, messages, and things like that. And with that, we reverse engineer the entire protocol. Sounds like we may be reinventing the wheel, but it gives us flexibility and independence. We don't have to develop at the cadence of the Zcash D team or the Zebra team. It gives us more or less black box testing. We do instrument the nodes. We do test all that stuff, so we can and do that, but typically it's just sending messages until we get the right response and then moving forward through there. And we did that with the entire network protocol, which then becomes sort of the first de facto network layer spec. There is a whole spec for the Zcash system, but this becomes the conformance test for the network. And that's the first layer of what we call the CPR tests. So do all the node implementations talk to each other? Do they conform to the network spec? Are all the network messages tested? Things like that. This is cool because if you want to create a new Zcash implementation, you can, and you can use the Ziggurat test suite to make sure that it conforms. On top of that, the next layer of the Ziggurat, if you will, is load and stress testing, performance testing, and then finally malicious actor simulation and the almighty fuzzing, which is where we find a ton of interesting stuff. Fuzzing, if you're not familiar, is sending random messages to the input. It just programmatically spins up like a bunch of nodes and then sends tens of thousands of different random bytes and things like that to nodes, most of which get rejected, some of which don't. Here's some test examples. There's ZG Conformance 1, which is the handshake, ZG Conformance 10, which is a block request and block sync, but seriously, there's over, I think, 120 different tests that we run currently on both Zebra and Zcash D. And if you go there, you will see app.runziggurat.com, which we're going to demo in a minute. But that is our web app that goes through all that stuff. This is the result of the first round of grants, which is a bunch of bug fixes. As I said, credit to Equilibrium, thank you. And those were all fixed and closed and merged by the Zebra team. Thanks in particular to Tior, who's, in addition to everybody else, very helpful. From there, once we feel like the single nodes are, robust enough, then we can move to network-wide testing. This is the whole stack for the network-wide testing. It starts with the network itself. The first thing we did was take the synthetic node and outfit it with a crawler. Whoops, oh no. Which outputs a sample JSON, goes into another tool called Crunchy, which analyzes it for very specific network metrics, like degree of centrality, closeness, betweenness, things like that. Outputs a state JSON, goes to the visualizer. Also goes to something we called intelligent peer sharing. Get to that in a second, but that's basically a way to sort of repair the network and make it more homogeneous by suggesting better peers to each of the nodes that we encounter. That comes back, goes back to the crawler, and on and on and on. And this is all theoretical right now. We've not done any of this on mainnet. Well, we've done the crawler on mainnet, but we haven't done the active peer sharing on main yet. But the findings we have been interesting. This is an example of the GUI. What we have on top in the yellow is the, I want to say, yeah, okay, well, it's the user agent, so good to see everybody's up to date for the most part. Most of the people are on 6.2. And then the protocol version is mostly 170018 with some 100s mixed in there. Wait, what the heck is this? There's not 4,000 nodes in the network. It turns out that Zec is not the only cryptocurrency that uses the Zcash network. There's another cryptocurrency called Flux that I believe is a fork of Zcash that uses the network but does not participate in consensus. This, I believe in Zebra, has been fixed where they sort of filter those out. It's kind of tough, but you can do a looks like a duck, smells like a duck, walks like a duck kind of thing. Quacks like a duck, not smells like a duck. I don't know what a duck smells like. But that was another interesting thing. So there's really probably 200 to 300 Zcash nodes and not 4,000. So that was interesting. We have this really cool looking force graph that's WebGPU and WebGL enabled that takes the input from Crunchy, and this is good. I mean, it's very pretty. It's kind of confusing to look at, but what it's really good at is detecting islands in the network. So, you know, if you have a bunch of nodes over here, then one very central node, then a bunch of nodes over here, we call that an island, and typically it's to be avoided, and for the most part, the Zcash network looks pretty good. These graphs, in addition to the next one, have been filtered so they do not include the Flux node. So this is the Zcash network, the Zec network, I should say. We also have a geographical display. Don't worry, we're not doxing anybody. This is very coarse geolocation based on free versions of the IP location databases and internet provider IP addresses and not specific node IP addresses. You can see these sort of clusters here, the ones that are bunched together, are all kind of reporting from the same region, not even really the same city. So just to get a sense of where things are, but not to identify anybody. And this is also really useful for the other types of network metrics that I'll show, like this one. This, I believe, is betweenness. So you can see this node is connected to all those other nodes, and it's very betweeny, which I'll explain shortly. Let's take a look at that. So this is app.runziggurat.com. This is the first thing that I showed with this graph here. I'm going to zoom in just a bit. And here's all of our tests that we run. A whole bunch of them. There's a spec for all these tests in our GitHub repo that explains what each of these are. Here's our malicious actor tests. Sending the wrong version, sending something after the handshake that shouldn't be sent, just stress testing, doing bad blocks, bad peer lists, things like that. Here's our force graph. It's all animated and nice. You can zoom in, zoom around. When you click on a node, or you mouse over it, you get information. But in here's our geolocation graph. Go Europe. Very Zcashy in Europe. It's nice to see. One fun thing is you press N while you're here, they all connect. But when you click on one, again, you see all the different connections. And you can cycle through the different metrics. So definitely check that out when you have a sec. You have a nice like FPS counter too. We got some good frame rates here. PlayStation people would be happy. So that's fun. So what does that stuff mean? Well, degree is the simplest one. Sometimes you'll just hear it called centrality. It's just the count of connections in the node. And the more connections a node has, the more central it is, the more of a degree of centrality it has. Betweenness gets a little bit more interesting because you have the shortest path between two nodes, and the more your node shows up on that shortest path, the more between-y it is. And then closeness is a statistical measure. You take all the shortest paths of all the nodes, and then you basically statistically assign scores to all of them, and that's how close your node is. The goal for these is to have a narrow range. So if one node is very betweeny and the other node is not, you want to scoot that all together so that they're all very close to each other in the measurement. And that way your network is more homogeneous. We would like to include the trail of bits DARPA report measurements in some future work, which is consensus influence, which means we would need to extend a little bit beyond the network layer to check that out. And eigencentrality, which is like a vector measurement of these things. But what if the crawler wasn't just passive? What if we weren't just measuring stuff? What if we were actively trying to repair the network? And this is where the intelligent peer sharing came in, with the goal of narrowing these metrics down. We did simulations on mainnet where we were able to increase and decrease certain measurements to get there, but that's just theory. We've not run that because, well, I don't want to take that risk. I don't want to be the guy that crashes the network by accident. Another interesting finding was that a lot of nodes are connected to themselves, which may be because there's IPv4 and IPv6, or because there's multiple IP addresses being reported, but that's just, something to point out. And then last month, the real fun began, and we actually did a red team exercise on testnet. We tried to pollute the network with fake nodes. We tried to do block request spam. We tried to do connection spam. And we looked at all the CVEs and all the known issues and tried to sort of poke and prod at those as well. I can share that we had varying degrees of success with all these things, and the degrees of success were dependent on whether it was a Zcash D or a Zebra node. That's as much detail as I want to get into on that right now. That report has been responsibly disclosed to the right people, and I'm happy to report that with the latest Zebra version, at least, many of these were mitigated. So, network's looking pretty safe, One of the tools we used was what they called an inverse crawler, which basically, instead of going around to all the nodes, it just kind of sat there and wait for other nodes to connect to it. And you can generate a interesting public and private. Some hidden nodes would connect, and then we would know about them too. So that's something to consider. And this new sort of tainter collector model, where that inverse crawler would sit there, but then feed out bad IP addresses and bad nodes to these tainter nodes, which would then go to the network and pollute things. Again, testnet, not on mainnet. We're not doing any of this. If you see any of this, it's not us. That's really it. I mean, that's the overview of what we've been doing, and I'm hoping there's some good questions that we can get into some discussion with the last few minutes here. Thank you.
Okay, there's a couple questions in Hoover. At the moment, Ziggurat tests are only run occasionally, but we could catch more bugs if we ran them on every node, change, or release. How can we make that happen?
Well, they run daily, so I don't know how much more often we need to do that. That should theoretically catch the new versions. When we do work with the teams they sort of will notify us and say, hey, there's a new version, could you check it out? And one thing that we could do is actually work this into the CI/CD of the actual mainline repos themselves. As of now, we've left that to the teams to do, but that's something we could explore.
In the Zcash network protocol, the IP addresses of all the nodes are publicly available. How can we improve Zcash network privacy?
Use a VPN. You know, like I said, we're not trying to dox people. We're not trying to find where exactly people are. So we do, in our reporting, very coarse geolocation. That doesn't shield the IP addresses of a naked Zcash node running out in the world from anybody else from checking that out. But in terms of what we do, we try to balance privacy, of course, with utility. So I'm open to ideas, too, about how we could do that better.
When you say nodes are connected, what exactly do you mean by that? Are you monitoring their connections?
Node connection usually means a successful handshake between the nodes, and this is debatable, and this is something we're in active discussion with the teams about. If the node shows up on their peer list, we assume they're connected, but obviously it just means that historically they've been connected to a node and doesn't mean they're currently connected. We optimistically assume connections in the case of that.
Instead of running the network improvements services, could we fix the node implementations instead?
Yeah, totally. They have. They know a lot of the bugs that we saw, a lot of the things that we fixed, the flux filtering, stuff like that has been a result of our findings. What we try to do is be sub-separate from the node implementation teams. So we, at the outset, said we don't work on Zcash, we don't work on Zebra. We only report stuff that we find, and then we leave that to the teams to do. However, in the last few months, there have been greater discussions about our teams intermingling with the implementation teams as well.
Well, that's all the questions we have on Hoover. If there's any questions in the audience, we can field those, but otherwise, we'll go ahead and stop it there.
Cool. Well, thank you. Oh, yeah.
Wait, there's a question in the back.
So, say this new SDK, like wallet D, is there kind of like a stack you can create to kind of easily test, like say you're just a UI developer who wants to play around with SDK. Does Ziggurat help with that kind of stack where you don't need to run all the big stuff?
Probably not. You know, the Ziggurat node itself is more of a full node. You could run it, as I understand, a lot of the light wallets are using the RPC endpoints or using the network port.
I think, well, in this case, it would be like wallet D on top of it, wouldn't it? For like the new UCC, like mobile wallet.
Okay.
So, what about just like wallet D and Ziggurat? Does that play any, is that any part of it?
No, it hasn't. We haven't touched that yet. Yeah. Sorry. Yeah. Yes.
What do you mean exactly by that there is another cryptocurrency running on top of the Zcash network? What does it really mean?
Flexa,
It's called Flux,
or Flux, yeah.
and it's a fork of Zcash, right?
I'm not sure.
Okay, yeah. And they didn't change any of the networking code when they forked it. So when you run a Flux node, it just connects to the same network as all the other Zcash nodes. It has a different block height. It has a different network port. It has all these different things that you can use to identify it, and they run their own consensus on top of the same network. So they share different blocks. They have different, well, really just share different blocks is all it is, yeah.
Have Zcash nodes been running their transactions as a result? I'm sorry, maybe it's a stupid question.
I'm sorry, have Zcash nodes been running?
Like, have they been a parasite on our network?
I don't think so. I mean, they haven't. It's noisy. It's more traffic, but I don't think it's actively harmed anything.
I see.
Yeah, it's just kind of annoying, I guess is how you could say it.
Yeah. Were you, sorry, another question.
Oh, go ahead.
Were you involved in analyzing the network spam situation from about 18 months ago?
No.
Okay. Would it have made sense?
I'm sorry?
I'm sorry. I understand the DDoS situation we've been going through. Is
The
a
dust
network
attack.
yeah, it's a network level thing, right? So
No, because that's more of a consensus layer thing. That's more transaction spam and transaction output spam. So we saw it, and we were aware of it, and we didn't learn anything that the teams didn't already know, I guess, is
got it.
a way of saying that, yeah.
Okay, thank you.
No problem.
Okay, if that's it, then we'll go ahead and stop. If
Thank
there's
you.
no more questions.
You can find me afterwards, too. I'm happy to talk to anybody.
Yes, and if there's any other questions, you can post them in the Whova, obviously, so we can answer them on your own time.
All right. Enjoy your lunch, peeps.
Yeah, thank you, Mike.